Welcome to episode 262 of CppCast, the first podcast for C++ developers by C++ developers. I'm your host, Rob Irving, joined by my co-host, Jason Turner. Jason, how you doing today?
I'm okay, Rob. How are you doing?
Doing okay. Any news with you? I know you've been looking at, changes with travel restrictions and everything. Anything to share with that?
Yeah, so my training that we had been talking about for the last several months in Stuttgart for the end of September, beginning of October timeframe is officially canceled now. But I mean, that's just looking, it seems highly unlikely that U.S. will be allowed into Schengen area, into the European passport zone anytime soon. So yeah, that's been canceled.
Right. That's unfortunate. Hopefully you can do the same type of training next year though, right?
Yeah, we are going to keep our ear to the ground, see what happens, and when travel things start to open back up again, make plans again.
Awesome. Okay, well, at the top of the episode, I'd like to read a piece of feedback. We got this tweet from Connor Hoekstra, who we had on the show maybe 2 years ago.
There we go at this point, yeah.
Yeah. So he says, on the most recent CppCast, Rob mentioned some podcasts taking summer off, and Jason asked, why don't we do that? And I replied, maybe we should. Retweet this or comment to show our love for CppCast. And then it has a lovely picture of two kittens hugging, saying, we love you, CppCast. Please don't leave us. And yeah, we were just joking about taking the summer off. I don't think either of us really need a break, although, yeah. Gets busy sometimes, but
yeah.
Plan on
at the moment, no plans to. And I think we both kind of feel like, man, we've had such a long streak of not missing an episode that we don't really want to miss an episode either. But
yeah, oftentimes, we miss like 2 to 4 episodes a year, but we haven't missed a single one yet. Knock on wood.
No conferences and no travel, and
right. So hopefully, we'll keep that streak going this year.
Yeah.
Okay, well, we'd love to hear your thoughts about the show. You can always reach out to us on Facebook, Twitter, or email us at feedback@cppcast.com. And don't forget to leave us a review on iTunes or subscribe on YouTube. Joining us today is Dave Hagedorn. Dave is a technical manager with TextNow, located in Waterloo, Ontario, Canada. He leads the client calling team at TextNow, the leading mobile app offering affordable cell and Wi-Fi-enabled phone service. Dave has over 13 years experience writing mobile and embedded software and tools in C, C++, Java, Kotlin, Swift, TypeScript, and Python. Dave started his career at BlackBerry Research in Motion, doing embedded C and C++ development and representing BlackBerry at the NFC Forum and GSM Association. He went on to work at a local startup where he did embedded development and wrote cross-platform C++ for Android and iOS. Dave has a bachelor's in applied science and computer engineering from the University of Waterloo. He enjoys cycling, running, powerlifting, woodworking, and curling. Dave, welcome to the show.
Hey, I'm really glad to be here. Really like your show, and just glad to be on it.
Well, awesome. Thanks for coming on. You say powerlifting and curling, and you don't mean like curling weights in this case. We're talking about brooms on ice, right?
Yeah, two separate sports. Yeah.
It's funny because as Rob was reading your bio here, and it's an interesting maybe factoid for our regular listeners, is I almost never read the bio before Rob does. So I'm always just like, sometimes it's pasted in just a few moments even before we actually start the interview. But as I was reading 13 years experience with embedded devices, my brain immediately said, okay, what was happening 13 years ago? What projects would he have been working on? And then I saw that you said you got your start at BlackBerry. Not a whole lot of BlackBerry development going on these days.
No, I don't follow it too closely anymore, but I think there's still branded phones. I think somebody picked up the rights to brand the phones again and is going to start manufacturing them, but BlackBerry themselves is not really in the phone business that I know of.
What was the operating system like when you were developing? What was that? Yeah. I don't know anything about it.
It was many. So BlackBerry had their own homegrown OS early on, which was a combination of like a core kind of embedded real-time OS that BlackBerry developed, and then on top of that they had like a JVM and like a Java runtime that you wrote the apps in.
Right. Okay.
So I wrote at the core embedded layer, right? So pure C, and then later, so that was up until what they called BlackBerry 7, like the BlackBerry 7 OS, and then BlackBerry made this jump to what they called BlackBerry 10. which was when they moved to QNX, or QNX is an operating system. So BlackBerry bought QNX and incorporated that into their OS. And that was their real big push into like making like a really modern smartphone to compete with like iOS and Android at the time. Right. So that was kind of cool. That we got to work on C++ a bit at that point because QNX had a proper like C++, like GCC, they use GCC, right? So you could write C++ on QNX if you wanted to. And then at the end, they just they capitulated and went to Android like everybody else.
Right.
So I worked on the first Android phone before I left. So I got to see that go out the door, which was kind of cool.
It seems like an interesting continuity, some sort of C-based operating system with a JVM on top of it, though, really, right? I don't know, it feels similar.
It's funny how like everything kind of goes in circles in tech, right? So
right.
Yeah, it's at a high level, it's not that different than what Android is today, right? I mean, if you think about it, yeah.
Yeah, it makes me think. I don't think we've had anyone on the show ever talk about like the Nokia feature phone days when there was some sort of Java applet gaming thing that was possible on those devices, on the old candy bar phones too.
Right. Yeah, applets were huge back in the day, I think, for stuff like that.
Okay, Dave. So we got a couple news articles to discuss. Feel free to comment on any of these, and then we'll start talking more about the work you're doing in TextNow, okay?
Yeah, sounds good.
Okay, so this first one I have is a post from JeanHeyd Meneide's blog, and this is Here I Stand, Free Allocators and an Inclusive STL. And it's a pretty long post, but this is going over JeanHeyd's efforts to show how you can make std vector and other C++ standard library containers exception-free.
Yeah.
What was your take on this one, Jason?
Oh, no, it sounds like, I've been kind of deep into some allocator stuff myself lately, which will show up in a couple of C++ Weekly episodes getting ready to come out. So I read this with interest, and yeah, as far as I can tell, he's completely right. It would take a relatively small change to the standard library to just allow you to specify exception-free allocators to your standard containers and let them magically become exception-free containers.
Right.
As far as I can tell, it's all there. I agree. It's a good article.
Yeah, and one of the things he talks about, an inclusive STL is that this is kind of one of the major complaints with game developers, that they would like to use the allocators or the containers, but they don't want to have to deal with exceptions.
Yeah, but although it does look like it might require an ABI breakage on Visual Studio's standpoint, but that's an implementation problem or detail, I guess, with Visual Studio.
Right. Dave, you have any thoughts on this one?
Yeah, I like the idea as well. Like, I don't think many people probably check for like std bad lock when they're using vector and stuff like that. So
yeah,
I think I'm not sure if like std terminate is always the right decision. Like, I think you'd want the ability to hook that in for your own needs, right? Depending on your environment. But yeah, I do like the idea. Right? It's kind of cool. Also, I didn't know you could. Sorry, I didn't know you could declare a function pointer as no except. I thought that was kind of cool.
Yeah, and then, he does a reinterpret cast for some extra damage there, but just to work around an issue, yeah.
Yeah, I've never had to do that, I guess, but yeah, interesting corner case in the language.
Right. For those of you who were like paying attention when I was hacking on the Doom engine, it's interesting that we're in this world where we're like, well, it's, we basically consider it impossible to deal with a bad alloc at this point. We just say the application's hosed. But Doom would try to allocate memory for additional resources like sound effects. And if it couldn't, then it would do things like free the older sound effects from its least recently used list so that it could allocate memory so it could load in the next thing for the next level. Like, applications at least used to do that as a normal part of programming.
Yeah, I guess these days just assume that if you're running out of memory, you're really in bad trouble since you have so much more available.
there's also the operating system detail. Like on Linux, I can call malloc 32 gigs on my laptop that doesn't have anywhere near that space available, and Linux will return instantly. It's not until you actually try to write to that memory location and it tries to allocate the pages do things go wrong. And that's we're already past C++ at that point. It's impossible for me to deal with that without using a operating system signal handling or something like that.
Right. Okay, next thing we have is this list on GitHub, Awesome HPP, which is a curated list of awesome header-only C++ libraries. And I like this just because it's very well organized. Like there's a table of contents of all the different categories of libraries that are appearing in the list. So you can find almost anything in here.
I like that it puts how many GitHub stars each thing has too, because that gives you a high-level idea of how used the library is.
Right. That's a really good point. So you can just, pick your category, go look at all the options, and have a good idea of which one might be kind of the most mature or most popular, at least.
I was kind of curious why they focus on header-only libraries. Like I know those are convenient, but there's also drawbacks to using header-only libraries, right? So they're kind of biasing your choice of frameworks to picking header-only libraries, which isn't always the right decision.
I think this is maybe meant as a direct corollary to the another library that's managed by a different person called Awesome CPP, which is in general a bunch of awesome C++ libraries.
Right.
Maybe. I don't know if that was intentional. That's how I looked at it anyhow when I saw it.
Right. Okay. Yeah, that makes sense. But yeah, there were definitely some really cool libraries there. There's one where they let you get the name of an enum at compile time, like the string value of an enum.
Right. Ooh, what is that? Deader enum?
Yeah, which one is that one?
Yeah.
It's called name of. Right. So they do this trick where they instantiate a template function that takes an enum value as one of the template parameters, and then they use like that pretty function macro to get the name of the function, which includes the template, or not the template, the enum name, right? Because it's part of the template, and then they like hack that string to get the actual. It makes me really want compile time reflection to get here today and not in 23 or 26 or whenever it lands.
Right.
Oh, but this looks, I had to click on the library since you mentioned it though. I mean, it's got broad support. Clang 5 or greater, which at this point is pretty darn old. GCC 7 or greater for parts of it. GCC 9, that's a little bit new, and Visual Studio 2017, I mean, most projects I'm working on are at least in this ballpark. Because it saves a lot of effort.
I do wonder what it means for compile time, because I was looking at the implementation and they don't know where your enum starts or stops, like in terms of values. So they do like a compile time, like I think they use integer sequence to instantiate, this template function like 200 times or whatever to cover all possible enum values in your enum. And then I guess they probably pick the ones that actually have a name in them, right? So probably not great for compile time, but really, really interesting.
That's really fascinating, actually.
Okay. Next thing we have is a blog post from Quarantine we've had on the show before. And this is standard library development made easy with C++ 20. And there's another interesting blog post where he's basically showing how you could rewrite parts of the standard library. In this case, he's going over std tuple and std pair. And if you use C++ 20, you could really reduce the amount of code necessary to write that out. But of course, then it wouldn't support earlier versions of C++.
Then the main thing that caught my eye, and I still need to come back to in this article to spend a little bit of time with, is the use of C++ 20's no unique address attribute, which I admit I don't really understand how it's used.
Yeah, I'm not too familiar with that myself. You have any thoughts on this one, Dave?
I kind of align with some of the comments in the article on backwards compatibility. I think it's really, it makes things hard in C++ sometimes, right? So especially if it's making it hard to maintain the standard library or to add new features to the standard library, I would fully support, okay, if I'm using C++20, I'm using a C++20 version of the standard library, right? That's not backwards compatible, right? And I think that would be a good thing.
Yeah.
Okay, and then the last thing I have, I actually got this tweet from the Vancouver C++ user group that they're going to be having a Canada-wide virtual meetup on September 1st, and this one is going to be hosted by Patrice Roy, or Patrice Roy will be the speaker for this event, and it's something C++ does right. So if you're in Canada and you're missing your user groups, definitely go check this out, 1st of September.
Have you been attending?
Yeah, I was just going to say, Dave, are you a member of either of these Canadian user groups?
Actually, no, I'm not, but I think I'll have to go look them up now.
Okay. Well, can you start by telling us a little bit more about what TextNow is and what you've been working on?
Yeah, for sure. So TextNow, basically our mission as a company is to provide excellent phone service for free or as close to free as possible. Right. So with that goal in mind, we provide two products. We have a free app, right, which is in the App Store and the Play Store. Right. And if you sign up for that, we give you a 10-digit phone number for free, and you can make unlimited calls and texts, over Wi-Fi, right? And that app it's ad supported.
Okay.
And then we have a second product which I'm really excited about. So this is in the U.S. We call it our free nationwide talk and text plan. And with this, we actually give you a free phone plan, right? So you can make unlimited calls and texts to the U.S. and Canada. It's on the Sprint network.
Oh.
It's totally free. Yeah.
That's interesting.
You do have to pay for the SIM card, but that's it, right? And then, yeah, the plan itself is free.
So is this also an ad-supported thing then?
It is, yeah. Like everything works through the TextNow app, right, which is ad supported. And then with those products we offer paid add-ons, right? So we offer data plans, we offer international calling, other types of products you might want in the calling space.
Okay.
All right.
And this is available on both Android and iPhone?
Yeah. Play Store, App Store, and then we also have a web app as well. So if you go to textnow.com and sign up or sign into your account, you're taken to a landing page where you can make calls or make texts or receive calls or receive texts. Right. So
Okay.
this is handy for people. Like if you're at your desk all day, you can have this open in another tab, right, as your phone, right, or as a second phone line or whatever you need.
Okay.
To do phone calls or texting for.
Okay. So, you have all this history in embedded C++ development going back to the BlackBerry days. So what sort of, app does this look like? Is it a C++ app on both Android and iOS? Is it cross-platform?
Right. So the apps themselves are, we have, our Android app and our iOS app. Those are two separate code bases, right? So our Android app's written in Java and Kotlin, and our iOS app is written in Objective-C, and we're moving to Swift, of course, like everybody else. But where I work on the client calling team within the TextNow, right? So we're responsible for the calling solution or the calling stack, whatever you want to call it, that these applications use. And that, what we've been developing over the past year and what we're moving to now is a new cross-platform calling stack that we use in both of our apps. And that's what we're writing in C++.
So this is the server-side thing, if I'm hearing you right.
Actually, this is the client-side framework. So TextNow does run their own calling infrastructure in the back end as well, which is one of the really cool things about TextNow. It's how we can have really good phone service, right? When we control both ends of the phone call.
Okay.
But there is a client-side piece, right, about how do we talk to calling infrastructure, right? and that's what we maintain. Right? So it's like a library that the rest of our apps import that has a calling API, right? So the ability to make a call, receive a call, all the things you would do with a phone call.
So, all right, then just to make sure I understand, this is a C++ library that will be used on both the Android and the Apple device.
Yeah, yeah.
Okay.
Yeah. Yeah, so we're at the point now where actually almost all of our Android users are moved over to this new library, and we've seen really positive results actually. So like users can opt in to give us feedback like through in-app surveys and stuff, and just through comments we've seen it in the App Store as well. We've seen it, general improvements across the board. So that's really exciting.
So you said, the Android app is moving or is finishing up moving towards the new library. What is it replacing? Did you just have a whole bunch of, Java and Objective-C code that was handling the old calling stack?
Pretty much, yeah. At a high level, more or less. On Android, it was Java code wrapping an open source like calling framework, like a calling. If you know calling at all, there's a protocol called SIP, which is Session Initiation Protocol, right? So we had incorporated some open source framework into Android with Java wrappers around it, and something similar on iOS. But it was two fully separate code bases, two different languages, and it's worked well for like a long time now and for our customers. But when we're looking forward to how we wanted to use, or where we wanted to take calling in the future, right? And we wanted to incorporate WebRTC, and just how can we make calling better and iterate faster? We really wanted to go to one code base, right, in some common language.
Okay. And can you maybe tell us a little bit more about SIP and WebRTC and what some of the advantages are of WebRTC?
Yeah, for sure. So WebRTC is I guess you could call it a framework for real-time communication, or that's what they call it. But it's basically a library for doing like real-time audio, video communication, right? So where you usually see it is it's actually in all modern browsers today, and there's a set of JavaScript APIs that all browsers, or I think all modern browsers support, that let you interact with this WebRTC library, right? So anytime you see any kind of video chat type solution like on a web page somewhere or a website, that's pretty much always WebRTC, right? There's a few exceptions, but I think pretty much everyone's using WebRTC nowadays. And it's an open source project. It's managed by Google. So they, typically it's just incorporated into browsers by browser vendors, I guess, right? So Firefox or Chrome or Edge. But you can also take this, WebRTC code base and build it yourself and use it in like an Android application or an iOS application or wherever you want to use it. But yeah, basically its goal is just high quality audio and video. So, it's adaptive to like changing network conditions. It has really good echo cancellation and silence detection and all these types of things that you want when you're doing video chat or when you're doing a phone call. So that's kind of the goal of WebRTC. I can definitely go into more detail, but that's WebRTC at a high level. SIP is all about call signaling, right? So WebRTC doesn't really define how you manage a call. It really just defines how two peers will set up a media stream to, send audio or video to each other. It doesn't dictate how you share the initial info that two clients need to find each other and connect, or how you do things like, update call status. Like, typically with a phone call, you've got like, the phone is ringing, the user's answering, those types of things, right? Or hold, conference calling, all these things. Those are all done outside of WebRTC. All right, so you need a framework or like a protocol for doing that, and what's often used in the telephony world is SIP, right? Which is just a protocol that basically covers all the cases you would ever need to cover in calling, right? So how you initiate a call, how you answer a call, how you hold a call, all these things, right?
So are you also using some SIP library that gives you those things, or is that's not built into WebRTC, it sounds like?
Yeah, it's outside of WebRTC, and yeah, we've pulled in a C library for SIP. It's open source. It's called OSIP.
Okay.
Yeah, and we've pulled that in, and are using that for, I guess you could call it like our call signaling layer. And then the other kind of cool thing that we're doing is SIP traditionally runs over UDP. I don't know why, because it's not like video or audio. It makes sense, right? Because you don't want to use TCP for those typically because it has too much latency, and if you drop a few packets, it's real-time audio, so it doesn't really matter. But SIP is over UDP as well, traditionally, which is, it has application level retries built into the protocol and all these things that actually kind of get in the way sometimes. So we do SIP over TCP. We actually use a protocol called WebSocket over TCP. And that just gives us, we don't have the headaches of UDP and retries and all that kind of stuff at the application layer. And it just makes the communication more reliable.
Just let the operating system handle that for you, basically.
Yeah.
Did you have to modify the SIP code to work that way?
No, actually. So the library we're using is fairly well abstracted. Like it doesn't take care of the sending or receiving. Right? It just provides stubs that you fill in, so you can plug in whatever communication layer you want.
Okay.
So that we use another open source WebSocket library to do that piece, right? And then the only other thing I'll say is we also use WebRTC in our web app, right? So again, if you go to TextNow.com, that's using the browser WebRTC APIs.
And that's the one that's already built into the browser.
Yeah.
Okay.
Yeah.
So does that mean you have like a cross-platform app across iOS, Android, and the web? Or is it a little bit different on the web still? Okay.
It's different on the web. So on the web, it's just pure JavaScript code.
Okay.
Interacting with the WebRTC JavaScript APIs, right?
Any plan to move to the C++ compiled to JavaScript?
Yeah, we've talked about it as like I think we talked about it in fun, kind of, right? Like, can we use any of our C++ code, like our business logic, say, right, around call management? Can we compile that to WebAssembly and use that in our web app? But no, we don't currently have any plans to do that. If it makes sense one day, and if it makes the calling experience better on the web for our customers, then sure. But yeah, where we are today is fine. So there's no need to do that.
So I'm curious how long this process has been ongoing of moving from the Java and Objective-C world to the shared C++ library.
Yeah, I would say around a year, or maybe just over a year. Right. So it's all kind of a blur now. But
no one knows what's happened in the last 6 months, so I guess it's fair. Yeah.
But yeah, we started with how can we incorporate, or how can we build WebRTC as a library that we use from, say, C++, right, which isn't typically how you use WebRTC, even in mobile. But we really wanted to do that because we wanted to use C++ and have a common language for everything, right? So we had to figure out a way to build WebRTC and incorporate that into our C++ library.
So is WebRTC a pure C library usually, or?
It's interesting. So the whole thing is built in C++.
Okay.
And then it does offer like a core C++ API. But that's usually wrapped by JavaScript in the browser, or on Android or iOS. The project provides Java bindings and Objective-C bindings, right? But again, that gets you back to like a 2 code-based solution, because now you're going to have Swift or probably Kotlin code controlling your WebRTC, and then you'd have to abstract that back to your common code somehow. Not really great. So we had to figure out how to like modify the WebRTC build process to expose the C++ APIs. And then the other really interesting thing we do is usually WebRTC is built as a shared library, right, that you load at runtime and you call through JNI in Java or what have you, right? We actually build it as a static library and then link that into our overall library, which we provide to the rest of our app. And that's just to cut down on the number of libraries the app has to load at runtime for startup reasons. And also it shrinks the WebRTC binary, I think, quite a bit, right? Because it's a really large library. It's like 6 or 7 megs when it's all compiled.
Wow.
So if you can link it statically and let the linker do garbage collection and throw away the stuff you don't call into, we probably save, from the stats I've seen, close to a meg of space, right? So that's significant.
So I assume the presumption is that you will, in fact, save engineer time and development hours moving forward after investing the effort in this new project.
That's the goal. Yeah, is that, if you want to change something in calling or add a new feature to calling, with our legacy code bases, you'd have to do it twice, right?
Right.
It's 2 changes, it's 2 pull requests, it's 2 repos, so 2 sets of reviewers, right? It really duplicates the effort in a lot of ways. And like I said, these I guess I'll call them legacy code bases have worked well for us, but if you can have a common code base, it just really helps a lot. And we're starting to see that, right? So, we're an agile company at TextNow, which is kind of cool. So we do weekly releases, right? And so we're releasing a new version of our calling SDK to our internal teams, our Android and iOS teams every week. And at this point, it's usually just a rebuild and like a version bump in the app that like pulls down the new library, and there's not really any API changes required, at the interface level between the app and our calling SDK. So we're able to keep a lot of our changes within our calling SDK, where we make them once.
How much thinner have the iOS and Android code bases gotten as you've integrated this cross-platform SDK? I mean, it sounds like this library is kind of responsible for a lot of what the app does.
Yeah, that would actually be hard to quantify. I don't really know the numbers very well. I do know that, like at a high level, that there is a lot of legacy Objective-C code in our iOS app around calling. And same on our Android app. There's a lot of legacy Java code that, it's kind of, it gets sprinkled throughout the app over time, right? Like any large code base, right? Separations of concern kind of break down and modularization breaks down. So we've been able to push a lot of calling logic down into like this common C++ code. So I do expect that going forward, we'll be able to go back and remove a lot of that like Java or Objective-C code.
Okay.
Do you have some way from the C++ library to say, this is the list of options for making a call or something like that, so that you can, when you make the changes from the C++ library, you effectively push those changes out automatically to the GUIs? Do you know what I'm trying to ask here?
Yeah.
Like
really.
the GUI asks the C++ library, so can you give me the list of features here? And then the GUI knows what to render, is what I'm going for.
So you mean like does this call support conferencing or something like that, and then the GUI would render like a conferencing button, or?
Yeah, I'm just curious how you keep the GUI and your library in sync. Does the library push things? Does the GUI ask for things, or is you just have to have communication between the members on the teams?
I see. Yeah. Just close communication between the teams.
Okay.
I would say. I mean, we do provide like a calling API to our apps, right? So if you change the API, the app won't compile, which I guess is one way of doing it.
Oh yeah, absolutely. Yeah.
But
I'm not going to argue with that.
But yeah, we don't. Yeah, I don't think anything like what you're saying. No.
Okay. Curious.
So you talked a little bit about, how when you're given WebRTC, you typically are given the Java and bindings for Objective-C. I'm guessing you're now having to generate your own bindings around your library, which is using WebRTC. What are you using to do that?
Yeah, so we use a cool tool called JeanHeyd,
Okay.
JINNI, which is from Dropbox. And
Right.
yeah,
Mm-hmm.
I think it's been mentioned on your show before, actually.
Yeah, it has, but yeah, it's been a long time.
Yeah,
It's been a while, and Dropbox I don't think is supporting it anymore, right?
yeah, they've walked away from it, and that's okay. Like what it does is it probably won't need to change for a long time,
Okay.
right? And it's something we could always swap out if we had to. But yeah, what it does is it provides a way of defining your interfaces between C++ and Java or Objective-C, right? So it starts with like an interface definition file, like an IDL type file, where you define all your interfaces and your other types and who implements them, whether they're implemented in C++ or whether they're implemented in Java or Objective-C. And then it provides like wrappers or proxies for those in the other language, right? So if that makes sense, it just provides a way of defining, who implements what, and then allowing you to call into that, right? And it's a really good framework, actually. I really like it. I like that it's IDL based, so if you change a definition and you rebuild all your auto-generated source code, you know, all of the code that consumes that definition now has to update to use the new definition, right? So you get, if you change something, you get a break at compile time, not runtime.
And this is the industry standard IDL you're talking about, right? Is that the...
Yeah, I don't think so.
okay.
I just call it IDL.
Okay.
Yeah, no.
I just had flashbacks to like the late 90s and RPC that used some industry standard IDL and I don't know. Yeah, like SOAP and that kind of thing. Yeah.
Yeah. Yeah. No, this just generates. I mean, yeah, it's its own little language.
Okay.
Yeah, and it works well.
Cool.
It maps. It has this kind of union of types that work across all languages, right? So like a stood vector is an array list in Java, is a NS array in Objective-C, that kind of thing. And it also manages memory really well, right? So if you're pointing to a Java object that implements some interface, you hold that reference to a shared pointer, right? So once all your shared pointers that point to it go out of scope, then the garbage collector can go free that Java object. Stuff like that. It's really neat how it works. Yeah, I mean, I could go into way more detail, but short version is it works very well.
That sounds very convenient. Yeah.
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 And I guess while, since we talked about Dropbox and Ginny, while you were working on this, I think the big blog post came out that Dropbox was unfortunately abandoning their support and their own cross-platform efforts. But I'm assuming you're pretty happy with the decision your team made.
We are. Yeah, I mean, some of the reasons in the Dropbox post I think it's fair to say, are challenges we don't face. Right? Mm-hmm. So they had issues with keeping their builds in sync, like with Xcode and generated code, or just code you build on Android and then build again on iOS. That's not really a problem we have because we use a different build system. We use Bazel, which natively supports emitting or just while building code for iOS, right? So, we're able to wrap all that logic in Bazel basically, and just say Bazel go build all this code for iOS, and then it does, right? So as we change our Genie definitions or any other code for that matter, Bazel can just pick all that up, or how we've used Bazel, it can pick all that up and just rebuild stuff for iOS. And then I guess the other point is we're not really coding GUIs and application level logic so much. We're coding like business logic, right? And call control and stuff like that. So, whatever language you do that in, it's not going to be that challenging, I don't think. Right. I mean, don't get me wrong, it's still a hard problem, right? You still have corner cases and race conditions and all. Like, calling is unbelievably complex, but it's a problem you could solve in any language.
Okay.
The C++ group that's working on this shared library, was it pulled from people from the other groups, or is it a new group that was created with Greenfield?
Both. So, there has been a calling team at TextNow for a while, and part of the reason I got hired at TextNow was to help with this effort, because I've done this before at a previous job. I did something very similar actually with Genie and with cross-platform
Oh,
C++.
okay.
And I guess that was appealing to the person hiring me. So, but yeah, there were also people on the team at the time that knew C++ and wanted to build a cross-platform calling SDK, and were fine to use C++ to do it.
Okay. Yeah, I was curious. I mean, you pretty much already answered this. If there was like a training or an issue in getting the rest of the team on board with this, or however.
Yeah. No. The team actually wanted to use C++ at the time. Like, we talked about a couple other languages, and there's other solutions out there. But we wanted to use C++ for a variety of reasons. One was to use the common C++ WebRTC API, and then there's also other frameworks we pull in. Like, we pull in Google's gRPC framework for talking to our backend, and that if you're using gRPC with protobuf version 3, I think that's only supported in C++ right now.
Interesting.
In terms of the cross-platform language space, right? So there were a few reasons for that. And yeah, since that, we've grown the team a bit. We've hired one person that knows C++ really well, and we've also had people that program in Java or Kotlin work on C++, and it hasn't really been a problem.
Awesome.
Yeah. So we're I guess you could say we're a cross-functional team.
Is the library you work on using the latest version of C++? Or using 11, 14, 17?
Almost. So we had C++ 20 turned on.
Oh, wow.
Wow.
And then we actually had to turn it off because we upgraded the version of gRPC we used, which was fine. Or actually, no, sorry. That had nothing to do with it. We upgraded our iOS toolchain, so our Xcode toolchain. And in that version of the C++ standard library, they changed one of the enums. In C++ 20, it's now an enum class and not a regular enum. I think it's stood memory order.
Okay.
And that broke our ability to compile gRPC code, because it does some weird things somewhere casting the enum.
Huh.
Right, so we had to go back to C++ 17 for that. But we do use designated initializers quite a bit, because those are supported already, like as an extension in Cline. And then we also use ranges. We've pulled that in.
Wow.
There's the ranges v3lib. So we're using the algorithms today. We're not really using the views much in our code base, except maybe a few unit tests, kind of for fun.
Okay.
But more just the algorithms, so we don't have to, pass begin and end everywhere.
Right.
And we've looked at stored source location as well, right? Because you can actually implement that in Cline 9. It has the compiler built-ins regardless of what version you're on.
Okay.
So we looked at maybe using that in our, we have an internal logging framework we use for application logging. And we've thought about maybe using that there, but we haven't yet.
I've been really looking forward to when I see official support for that from one of the compilers, so I can make an episode about it, basically.
Yeah, you can roll your own implementation today. Like, you can use the client built-ins, and it does work. Like, it's not too bad.
So it sounds like you're using Clang on both platforms then. Yeah, almost certainly, right?
Yeah, so the Android NDK for a long time now has kind of standardized on Clang.
Yeah, right.
And then same with the Xcode toolchain. Right? They've been using Clang for a long time now. Apple uses their own build of Klein, which has kind of some secret stuff mixed in sometimes, which can cause problems. But yeah, it's pretty much Klein everywhere. And then we also use Klein. Like we also build our code for desktop, which lets us do a lot of development without having to load an app on a mobile device, right? So we can just iterate that much quicker. And we use Klein there as well. So yeah, Klein everywhere.
So you said you had turned on the C++20 flag and then had to turn it off again, but you also said that you are using designated initializers, which I know is supported as an extension on the compilers. Just curious if there's anything else that you had momentum moving towards C++20 that you had to roll back because of that change.
No, we got lucky on that one.
Okay.
Yeah. Nothing. Yeah. Nothing
No
else
extensive concept support or anything like that.
Yeah. Well, we're still on at the time, and we haven't really bothered to upgrade. We were still on Klein 8, which I don't think has really good.
No.
Yeah. Yeah. So, but I'm very much looking forward to concepts and really looking forward to modules, right? But I think modules is like probably a year away. By the time build systems pick it up, and by the time Bazel picks it up and integrates it, so I don't know. I'm kind of sad because there's a certain amount of developer fatigue that goes with like editing your header file and then editing your CC file, like over and over, right? If we could stop doing that's really all I want modules for. I'd be so happy. Right?
The killer feature of algorithms is just to not be able to pass begin and end, and killer feature of modules is less header file fatigue.
Yeah. Basically,
I accept this.
Yeah.
Modern C++ to write code faster. I want to move in that direction.
Right.
Yeah.
So you already mentioned that Apple kind of uses their own secret sauce version of Clang that's difficult to tell what version it is, but it sounds like you're approximately on Clang 9 on both platforms, something like that?
Probably, I would say.
Okay.
Yeah, it's hard to say because we haven't, outside of those key features that I mentioned, we haven't ventured too far forward into like C++20. So we don't really get to see what breaks when you try to build it on iOS. But probably, yeah. Like we, as a company, we usually stay current with the latest version of Xcode, right? So whatever version of client that pulls in will be very recent.
We've had a lot of discussion on the show lately, which, since you said you're a listener, about ABI breakage, but it sounds like you're not relying on any binary blobs where this would be a problem for you.
I don't think so, no. Like we build WebRTC from source, and we build all of our code from source, and then we link it all together. And we know that when we build WebRTC and then when we build our code, we're using the same version of the standard library.
Mm-hmm.
So as far as I know, we're okay there. Right? It gets a little tricky because when you build WebRTC, it's its whole own entire repo and build system. And they have all their own in-tree dependencies. They have their own in-tree libc++ and their own in-tree, lib boring SSL for SSL and libgRPC and all this stuff. And we have all those same libraries in our code base, right? We use SSL. Right. We want to make sure our phone calls are secure, right? But we've done our homework to make sure that the versions that both link in at build time end up in the final binary and are compatible.
Right.
Yeah.
Just did a recent Twitter poll. How many copies of zlib are linked into your current project? And I think 5 was the highest number that came back because of stuff like that.
Yeah. Well, that's every shared library your app pulls in, especially on Android, because the default there is to link in libc++ statically into your shared library or whatever you're building, right? It does cause a lot of duplication.
Yeah.
Which is, again, why we're trying to link everything as one giant library for our apps to consume for that reason.
I understand that. Yeah. Other projects I've worked on have moved in a similar direction for similar reasons.
Right. It's a really interesting kind of challenging problem, but yeah, it's worth it.
Mm-hmm.
You mentioned they use Bazel as a build system a couple times. We have not done an episode on Bazel yet, and anyone listening from Google who would like to do an episode with us, please reach out. But would you tell us a little bit about your use of Bazel? Does it work well for iOS and Android projects?
Yeah, I mean, the short answer is it's working really well for us. I mean, I guess the goals of Bazel as a build system are to be fast and correct,
Mm-hmm.
and then
That sounds good.
multi-language as well. And also, I'd say it's really extensible. So we're able to use it to build like all of our, C, C++ code, all of our Genie code or generated code is Objective-C and Java. We can build all that. We can build all of our Kotlin code. The one exception is we don't build our Swift code in Bazel.
Okay.
We could, but it's just, it's much easier to work with Swift in Xcode where you have code completion and all that kind of stuff. Right,
So you use Bazel to produce the calling SDK, and then the app team uses just native Xcode?
Kind of. So we use Bazel on Android, yes. Everything's built through Bazel, and we provide like an Android archive, like a .aar file that goes up to our Android team, and that has all the Java bindings to Kotlin bindings to our calling API, and everything else that we need. On iOS, we build everything up to the Genie layer, which is the top level, like Objective-C wrappings around our calling API.
Mm-hmm.
And in Bazel, we can build that as a static Objective-C framework, I think it's called. And then in Xcode, we link that into we have a Swift project, which provides like nice Swift bindings over top of all of our Genie code. Plus all of there's a bunch of platform-specific support code that we need as well for our calling framework, right? Like audio management, detecting network changes, that type of stuff, right? So that's all in a separate Swift project that is in Xcode, and then we link everything together there and give that as a framework up to our iOS team.
And this whole process works well with continuous build environment you have set up?
It works really well. It took a while to get Bazel to play nice in a CI environment.
Really? That seems like that would be I don't know. I'm just surprised because...
Yeah, so, I mean, it works, but if you want it to work fast, I think that was the challenge we had. Mm-hmm. So Bazel does really extensive caching of all of its intermediate build files and everything, basically.
Okay.
And you can cache all that stuff remotely, but it also caches it locally on the local file system. And it wasn't really well documented early on in the Bazel days how that all worked and like where this file system cache is and how it works. And it turns out it's long story short, like to get builds in CI to use this cache consistently and to use cached build results from previous builds, it takes a lot of kind of investigation and just fiddling with your CI setup. To make sure like incremental builds are really fast, right? Because if you're not careful, Bazel will, every time you do a CI build, it's somewhere else in a different directory on a different machine, right? And that causes Bazel to go look in a different location for build, like cached build results. If that makes sense.
It does. I've seen similar issues with Ccache on CI systems. Right. Just trying to say, yes, this is in fact the artifact that I want you to use, even though the build folder is a different directory or whatever.
Yeah, and then you also have to be careful. Like the file system local cache isn't multi-build safe. It's meant to be used by one Bazel process at a time or one Bazel server at a time. So you have to be careful to like serialize your builds on a given node. Just things like that. But in the end, it's really paid off. Like a full build of all our stuff, gRPC, SSL, our code, all this stuff for 4 Android architectures, 4 iOS architectures. It's about 20 minutes, right? And with remote caching, that gets down to like maybe 13. Wow. And if you can use local caching consistently on like a warm node or a hot node, rebuilds are like maybe a minute or two.
Okay.
So really, yeah, really great.
Handy.
Yeah. Well, Dave, it's been great having you on the show today. Is there anything else you want to let our listeners know about before we let you go?
No, I'm good. Just thanks for having me on. I really appreciate it. It was a lot of fun.
You have a Twitter handle or anything like that if people want to follow you?
I don't. I don't do the Twitter.
Okay.
I've got my email, right? So dave.hagedorn@textnow.com. If anyone wants to get a hold of me.
All right. Awesome.
Very cool. Thanks,
Thanks
Dave.
a lot.
Yeah, thank you. Have a good day.
You too.